Hi, this is Aaron Lewis again from Franklin Maths. This video is on Surds. So, the textbook that I've been talking about in the other videos is this one right here. All the videos do point to the exercises in that book, and same with the second year book there. I'm not endorsed by those companies at all, it's just that the textbook that we're using here at Franklin. And this is the calculator that we use in the college as well. We won't be using it in this video, but we will do in later videos as well. Right, so the first thing is, what is a surd? It should have been covered at GCSE, but it doesn't matter, we'll have a look now. So a surd is any sort of root which can't be written as a whole number. So for instance, something like the square root of 8 isn't a whole number, so that is a surd. Something like the square root of 4 though, which is actually 2, so I do get not just a whole number, it could have been it could have been just a rational number, it could have been a fraction. That is not a surd. And we can think of lots of examples, so think of something like the cube root of 90. Well, that's also a surd because I can't think of a cubed number which is 90. And something like root 2 as well. Root 2 is also a surd. And what we really mean is that it can't be written as a fraction. So a surd is basically a square root, cube root, fourth root which can't be written as a fraction. Okay, we're thinking, well, Aaron, 2 up here isn't a fraction. Well, 2 is, isn't it? It's just 2 over 1. Okay, so a surd is just any number which can't be written as a fraction. And you might be watching this video going, oh, hang on, how do we know that? The proof of this will be in a later video and is part of the A-level course. Okay, so we'll have a think about some of these now if you want to have a little quick check. So square root of 7, the cube root of 27, the square root of 5, the fourth root of 81. So the square root of 7 is a surd. I mean, you could check on your calculator anyway. It will give you a decimal approximation, never ending decimal. This one's a surd as well. You might say these are irrational numbers as well. Cube root of 27 is 3, and the fourth root of 81 is also 3. So these two down here are not surds. That's that one. And that one. So that's a brief overview of what a surd is. It's just a square root, cube root, or any other roots which can be written as a fraction. Okay, so one of the things we have to do in this course is to manipulate surds. Now, the way I do my lessons is I will do a nice example on the left. You don't need to write that down, you just need to watch, and you do the example on the right. My advice for this would be to do this in silence. When you watch this, have some nice peace and quiet at home, and then work from there. So what I'll do first is I'll do it in silence and I'll talk through it. Okay, so what I've done here is I've got root 80 and I look for the biggest square number that goes into 80, and in this case that would be 16. So it's root 16 times by root 5. Now one of the laws of indices is a to the n times b to the n is equal to ab to the n, and that's just basically this surd law here. So you just split it up into its the largest square number you can think of that will go into it, and then root 5, and the root 16 then obviously that isn't a surd, that is an actual number. Root 5 still a surd, and we leave it like that. Okay, here's yours to do. Have a go at that, pause the video and compare in a second. Okay, so looking at root 50, we think about the largest square number that goes into 50, which in this case is going to be 25. multiplied by root 2, and the square root of 25 isn't a surd, that is 5, times root 2, which is 5 root 2. Okay, it's quite nice to do, quite nice to work with the surds. They're a little bit like algebra, apart from there's a couple of sort of special rules, so I tend to treat them as a piece of algebra, and then manipulate further on. So hopefully you got that one. If you didn't, have a look at mine and get it corrected. Okay, so here's my next example. Again, I'll do it in silence. You can just watch, and then you can do the you do bit. Not much to say or do on this one, so again, I'm treating it almost like a piece of algebra. 7 lots of something. I'm not going to get too stressed that this is root 7. Minus 5 lots of the same thing is going to give me 2 lots of whatever the thing is. So in this case here, we've got the same bases here on these surds, so I can just do 7 minus 5 is 2 root 7. Easy enough to do. And here's yours to do. Okay, so let's have a look at that one. Hopefully you just looked at it and you could do it in your head without any problems. So this one then, we've got 2 root 5 plus 6 root 5. They're both the same base. Let's check that before we start, otherwise we can't really do anything. So that's going to be 8 lots of root 5. Okay, easy enough to do without any stress or problems. Okay, so we're going to step up a little bit now. We're going to be able to manipulate these a little bit further. Okay, it is what we've been doing before. So again, I'll do this one in silence, then an audio over it, and then you can have a go at the other one. Okay, so as I said, this is a combination of the other two things we've done. So root 63, I think about the largest square number that goes into 63, so which is 9. So it's 9 times root 9 times root 7. And do the same thing, and I'll notice here, and questions are sort of engineered like this. I've got the same base here, so 9 root 7. Sorry, root 9 lots of root 7, root 4 lots of root 7. This can be manipulated into 3 lots of root 7 because the square root of 9 is 3. Keep the plus sign. Root 4 is 2 multiplied by root 7, and it's very similar to the problem we had a second ago. So 3 root 7 plus 2 root 7 is 5 root 7. So here's yours to have a go at. Pause the video and we'll have a look in a minute. Okay, so having a look at these, the biggest square number that goes into 75 is 25, so that's root 25 times root 3 plus, and the biggest square number that goes into 48 is 16 times by root 3. So it's very similar in style to the previous one. So this can be 5 lots of root 3 here plus 4 lots of root 3 here gives me 9 lots of root 3. Now you're probably asking, Aaron, I could have just bunged this in my calculator. In the exam, if they asked you to simplify this and fully justify your answer, you need to be able to show every single step of working. So just watch out for that. And obviously this is a useful skill anyway. It shows your understanding of surds. So hopefully you got that. Well done if you did. Let's move forwards. So what I'd like to do is exercise 2b. I'd just like to complete question 1 from that. So pause the video now, have a go at that, and then press play when you've done and marked. Okay, so let's move on to the next little section. So this is an interesting skill, and it's not often taught at secondary school, but we'll have a look now. So this time I'm asked to write this surd here, 7 root 7, in the form root a. Okay, well, all we're going to have to do now is reverse what we did a minute ago. So let's think about this. So we've got, again, I'll do this one in silence before I start going on, and then I'll talk over the top. Okay, so this is a bit weird, and we don't often see it done backwards, but it's a useful skill to be able to do. So notice here, this 7 must have come from somewhere. This must have been a square root. So, you know, what we are using square roots here because there's a square root symbol here. If it's cube roots, then it's a different sort of problem. So 7 must have been the square root of 49. And root 7 is just root 7. And what we can do, we can reverse what we did before. So we can put the 49 and the 7 inside of the square root symbol, just using that third law we saw earlier. And then I can do 49 times 7 in there. Okay? Here's yours to have a go at. Okay, so hopefully you paused it and you've had a go. So you're going to take the same approach here then. I've got, if my pen lets me right, there we go, 6 root 10. We need to think about this then. So where did that 6 come from? Well, the 6 must have come from the square root of 36. And this is multiplied by root 10. Remember, no sign means times here. And so therefore then, this is going to be the square root of 360. Okay, and you can just pick up a calculator and check this, but make sure you can do this in reverse fashion. I don't often see this done, but it's quite a useful skill to look at and be able to do. Okay. So another example. All these examples do match up with the questions in the on the worksheet, or sorry, the textbook. So it's going to be very similar to what we did a minute ago. So I'm going to do this one in silence, and let's see how this one's going to work. Okay, so the first thing I did here is I didn't really have a place to go really with this one. So what I decided to do was to put the roots together first. I said treat it like a piece of algebra. So root 3 had 2 root 3s, 3 root 3. And then I did exactly the same as I did on the previous slide. So 3 must have come from the square root of 9, and root 3 is just root 3, and I put them back together. Okay, nice and easy to do. Again, you can check this in a calculator. Apart from it will give you the answer of 3 root 3. Okay, so here's yours to do. Pause the video now, have a go, and I'll check in a second. Okay, so with this one, it's worth just looking. The bases are the same, so we can put them together. So in this case here, this is going to be 7 lots of root 2. And go through the same thought process again here. 7 must have come from somewhere, and it must have come from the square root of 49. Multiplied by the square root of 2, which is going to give me the square root of 98. If you bung this in your calculator, press equals, it'll give you 7 root 2, and hopefully you can see how that matches up there. Nice and easy to do, but worth being able to manipulate this. You're going to get all sorts of things at A-level maths, and being able to manipulate Surds is really, really useful. Okay, I've got another example this time, a little bit more difficult, and I'll do it in silence, so you can just watch and then do the one on the right. Okay, so let's have a look then. So the first thing I decided to do, and there's not much I can really do with this apart from if I can get rid of this plus symbol. So the square root of 48, we can work with this. So the biggest square number that goes into that is 16, multiplied by root 3, plus another root 3. Notice that this here can be manipulated. So the square root of 16 is 4, root 3 comes with it, plus a root 3 here. 4 root 3's plus a root 3 is then 5 root 3, and I can go through the same process I did on the previous slide. So the 5 must have come from somewhere. Be the square root of 25. The root 3 can stay where it is, and then we can just multiply these two together. Okay, and again, I'm just upping the difficulty on every single slide to give you that that success, so you can make more progress and be more motivated. Here's yours to do. Pause the video and have a go. Okay, so hopefully you've had a go at it now. Just lost my pen a second. Where's it gone? There it is. Same thing here then. So root 50 is the square root of 25 times the square root of 2 plus the square root of 2. So it's going to be, show some equal signs there. This is going to be 5 root 2 plus root 2, which is going to be 6 lots of root 2. Same process again. Where did the 6 come from? Came from the square root of 36 times the square root of 2. So that's going to be the square root of 72. Okay, so you can try this in a calculator and make sure it works. Okay, so could you complete questions 2 from exercise 2b? All the examples should match up to each start of questions. And when you're ready and you're marked, press play on the video. Okay, so in this section we're going to do a little bit more manipulating of these surds. I say, if you treat it like a piece of algebra, you can't go wrong here. You've got those final little rules to do with surds. So I'm going to do the same thing again. I'm going to work in silence so you can just watch what's going on, and then you can do the one on the right. Okay, so with this one, notice I've got brackets and with the plus sign in the middle here. So it's just like algebra we would have done in maybe year 8, year 9. So I've drawn the arrows over the top. You don't need to do that, but you do it in your head, then fair enough. So 5 times 4 is 20. 5 times root 7, again, if you imagine this was an x, you'd have no problem with it. So 5 times root 7 is just 5 lots of root 7. This one here, 2 times 2 is 4, and 2 times negative root 7 is minus 2 root 7. And we're just going to collect the like terms now. So 20 plus 4 is 24. 5 root 7, take away 2 root 7 is going to be 3 root 7. Easy enough to do, and it's quite nice as well to follow on. So here's yours to have a go at. We'll check in a minute. Make sure you pause it. Okay, so the solution to this one then. I'm not going to draw the arrows over the top this time. So 2 times 6 is 12. 2 times minus root 3 is minus 2 root 3. Minus times 7, it's minus 1 times 7, or you change the sign when you multiply by a negative. Minus 7. And then minus 1 really times minus 2 root 3 is going to be a positive 2 root 3. And we're going to collect like terms. So 12 take away 7 is 5. Minus 2 root 3 plus 2 root 3, well, they cancel off, so 5 is my answer there. So in this case here, write in the form a plus square root of b, where you could write in the square root of 0, but it doesn't really matter in this case. And that's it, finished with. Okay, the next example. Do the same thing again, work in silence, and notice this time there isn't a plus sign here, so we're going to have to multiply these two things together. don't think that's the best example I've ever chosen, but you don't have to use grid method here. I've just gone for it because I thought it'd be neat for me to write, and it hasn't turned out like that. So if you go for, I don't know, maybe foil, monkey face, whatever it may be that you've been taught, stick with that. So let's have a look then. So whichever way you do it, 4 times 2 is the 8. This gives you that 8 there. 4 times minus root 7 there will give me that minus 4 root 7 there. Now 2 root 7 times 2 is going to give me another 4 root 7, well that's going to be positive. Now here, what happens here then? Now if you think about it, if you've got the square root of something, and you multiply it by the same thing, effectively square it, it becomes the number. So a little bit down here, root 7 times root 7 would give you 7, wouldn't it? If you think about it. That's just one of the special rules with surds. If you multiply by itself, it becomes the number which is inside. So that's the only thing where it's sort of different to algebra. And if you think about it, if we multiply that by 2 then, or in fact, 2 and then by negative, you're going to get minus 14. So just watch out for that bit there. So that's root 7 times root 7, which is 7, times by 2, which is 14, and then with the negative on it. So when you look through this then, these two middle terms here cancel out, and you're just left with 8, take away 14. If you do get stuck, it probably will be with this bit here, so just be careful with that. Obviously you could use a calculator to work that out, but if you can do it just by going, okay, so the square root and square root multiplied together will give you the whole number in this case. Okay, here's yours to have a go at. Okay, so here's the solution. This time I'm not going to draw a grid for it. Just lost my pen there. Okay, so 6 times 7, I'm just going to go with the arrows over the top. 6 times 7 is 42. And then 6 times minus 2 root 3. Well, 6 times 2 is 12 with the negative, so minus 12 root 3. This one here then, go underneath this time. Minus root 3 times 7 is going to give me minus 7 root 3. And I say this one here is the only ones which might represent the problem. So let's do it in stages. First of all, let's sort the sign out. Negative multiplied by a negative is a positive. We've got a 2 here, but then we're multiplying root 3 by root 3. Now root 3 times root 3 is 3 times 2 will give you 6. So that was root 3 times root 3 is 3, not 9. It would be the square root of 9, which will give you 3. Times 2 is 6, and the sign is positive. And then let's sort this out how we can. So 42 add 6 is 48. Minus 12 minus another 7 is minus 19 root 3. If you got that, great. If you didn't, and it was this bit here, it might be worth having a bit of a practice. 2 root 7 times, I don't know, let's say 4 root 7. 2 times 4 is 8, and root 7 times root 7 is 7, which is 56. Okay, so just watch out for that. Okay, I think this is the second to last example in this little section here. So with this one here, again, I'll do it in silence, and then you can get on with the right hand one. Okay, so with this one here, first of all, we notice we're squaring the brackets, which means we're multiplying the bracket by itself, so you have to write 2 brackets out. So 4 times 4 is 16. 4 times 2 root 7, again, treat it like a piece of algebra in this case. That's going to be 8 root 7. Same with this middle term here. And then this last one here, just be careful. So first thing I'm going to do is 2 times 2, which is 4. And then root 7 times root 7 is 7, which is why it gives you the 28. Again, it's just one of those that we just looked at a minute ago. Here's yours to have a go at. Pause the video and see how we get on. Okay, so with this one here, I'm going to rush to this one. So 6 minus root 3. 6 minus root 3. Maybe not rush that quick because my handwriting's going skew. Let's have a look then. So 6 times 6 is 36. And 6 times minus root 3 is going to be minus 6 root 3. We're going to get that again. There is a general rule for this. If you know it, use it. And then the last term here is going to be a plus. And it's going to be a 3. Okay, so minus multiplied by minus is positive, and root 3 times root 3 is 3. Now you might write that as root 9, which is, again is 3, so it doesn't really matter. So this is going to be 39 minus 12 root 3. I know it does say there, write that as a single square root, but don't worry about that. I've just probably miscopied what I was supposed to put. If you got that, great, well done. Okay, last example of this little section before we get into rationalizing. So if you know the difference of two squares, use it here. I'm going to go through the full method so you can see what's going on. So same thing as before. In fact, I'll do it in silence again and I'll narrate over it. Okay, so with this one here, I've employed exactly the same tactic as we did before. I've expanded the bracket, so 5 times 5 is 25. 5 times minus 2 root 7 is minus 10 root 7. Same for this one underneath, apart from this one gets a plus sign. And this last term here, minus times a plus is a minus. 2 times 2 is 4, and root 7 times root 7 is 7, which gives me minus 28. Now you notice here, these middle two terms cancel out. Okay, and this is the difference of two squares. Okay, so the difference between really 5 squared and 2 root 7 all squared. So effectively it's the difference of 5 and 28. In this case it's a negative difference. Okay, so if you already knew that straight away, you knew that it's just that one squared, take away that one squared, that's absolutely fine by using the difference of two squares. Otherwise you need to write it out fully until you've seen enough difference of two squares. Right, here's yours to have a go at. Okay, so hopefully you've had a go at that. Those of you that have got a key now will know, hang on, root 12 can be manipulated. Yeah, it's a bit of a mistake from me there, but it doesn't matter, I'll manipulate at the end. So, what we're going to have then, we're going to have 4 minus 2 root 12 plus 2 root 12. So we're looking, it's the same bracket, just with the opposite sign, so they should cancel out the middle terms. So what we're going to have here, I'm going to have a minus, root 12 times root 12 is 12. So to clean this all up, 4 take away 12 is minus 8, and done. Well done if you got there. Okay, so could you complete question 3 from exercise 2b? Be great, thank you. Okay, so I do realise that this is quite a long video, but it's worth being able to master the basics before I move on to anything particularly difficult. And this lesson is quite chunked, it's why I do it in my lesson. So our lessons are an hour and a half, so you've probably been at this now for probably about an hour, which is pretty good. In terms of, yeah, it could be homework as well. Right, so do the same thing again, run through it, and I think this is the last little section. Okay, so with this example here, it says rationalize the denominator. So all we want to do is turn the denominator here into a rational number, basically a fraction. If 7 is a fraction, it's like 7/1. So all we're going to do is think about how can we turn root 7 into a rational number. So with this one here, using the rules of equivalent fractions, whatever you multiply the numerator by, you must multiply the denominator by, or the other way around. So if you multiply top and bottom by root 7, now at the top there, 8 root 7 is just 8 root 7, but root 7 times root 7 will give you 7. Well done. If you already knew that, so here's yours to have a go at. Pause the video and I'll put the answer up in a second. Okay, so with this one here, it's just 2 ignore that. 2 over root 3. We're going to multiply top, numerator and denominator by root 3. So you're going to end up with 2 root 3 over 3. Nice and easy. Well done if you got it. This is what you probably had a lesson like this at secondary school. Right, moving forward, let's have a look at this one then. Again, I'll do it in silence and I'll narrate over the top. Okay, so with this one here, what I've decided to do is just multiply by root 2. I could have multiplied by 2 root 2, but then you'd have to cancel the fraction down. You'd end up with 10 over 8. So what's happened here then? So 5 multiplied by root 2 is 5 root 2. Now this denominator, we looked at this on the earlier slide. So root 2 times root 2 is 2, not 4. Multiplied by 2 is then 4. Okay? Now you could have put it in your calculator, but it's worth realising why root multiplied by root will give you sort of the number inside. So that's root 2 times root 2 is 2, times 2 is 4. Here's yours to have a go at. Pause the video and have a go. Okay, so here we go. So I'm going to go to the side here and save a little bit of time. So this is going to be multiplied by root 3, multiplied by root 3, and we end up with 7 root 3 on top. And what we end up with down here, so root 3 times root 3 is 3, multiplied by 3 is 9. Okay? So it's fairly nice and easy to do this bit. Okay, same as before, here we go. Okay, so with this one, you notice that it's ever so slightly different. We've got 2 terms on the numerator here. So we're going to do the same thing. We're going to multiply top and bottom by root 7. Now you notice here, I've just moved that root 7 to the front here, and I put this numerator here in brackets. And that's because both things here need multiplying by root 7. You can't just multiply one of them, both things must happen, which is why I've rewritten it out here. And after that, I'm just, so that it's supposed to be a 7 there, not a 4. It's my terrible handwriting. I've just then expanded the brackets, noticing that root 7 times root 7 is 7. I know that can be, I could split it up into 2 separate fractions, but for now I'm just going to leave it alone. Okay, it's nice and easy to do, just watch out for that single bracket. Here's yours to do. Pause it and have a go. Okay, so with this one, multiply top and bottom numerator and denominator by root 8. And the denominator here is going to be 8. And the numerator, then we're going to multiply both of these terms by root 8. So it's going to be 4 root 8 plus 8. So we're multiplying both of those there. We can manipulate this further. So let's have a look. So root 8 is going to be 2 root 2. But for now, I'm going to leave it there. I'm not going to get worried about that right now. But if you can manipulate it further, then do. In fact, let me just bung the answer. I've changed my mind. So it's going to be 4 lots of 2 root 2 plus 8 all divided by 8. So that's going to be 8 root 2 plus 8. Really apologise for my handwriting there. Is then divided by 8. And then we can divide all these terms by 8 here, so you can have like root 2 plus 1. So if you manage to get that far, great. If you got to this line, that's amazing as well. So don't worry about if you don't understand these last few lines here. Okay, last couple of examples. So I've got to do the same thing here. Now these ones here are a bit of a step up, just down to the nature of what they are. So again, I'll do it in silence and let's see how we get on. Right, so I don't think I could have chosen a worse question for an example there, but never mind, and I really apologise for that fraction line. That is horrific. Right, so when we're trying to rationalise the denominator, if you multiply like 9 root 5, if you multiply by the same thing but change the sign and use that idea of difference of two squares, look, it will cancel out. So whenever you're trying to rationalise and you've got two terms, take the same two terms and just change the sign. Okay, so let's have a look. So the numerator here, 3 times 9 is 27. Again, I put the brackets in just to see what's going on. 3 times root 5 is root 5. Sorry, 3 root 5. Root 3 times 9 is 9 root 3. And root 3 times root 5 is root 15. So that's the numerator done. Now the denominator here, same thing as I've just done a minute ago. Not forgetting that root 5 times root 5 is going to be minus root 5. So, and that leaves me there. It's not a really nice example, but it gets the math through. So here's yours to do. Pause it and have a go. Okay, so with this one here, I'll just sort of rush to the answer. So I'm going to multiply this time by the same denominator, but with the opposite sign. Now we'll be doing this at speed, so make sure you just check what you're doing. So we're going to have, I'm going to sort the denominator out first. Got these things to work. So difference two squares, so it's going to be 100. Now we're going to get plus 10 root 2 and minus 10 root 2. And we're going to get minus 2 out the end here. So what I'll do is I'll just jump ahead with my denominator. So we end up with 98 on the bottom. So the numerator up here, so we're going to have 7 times 10, which is 70, plus 7 root 2, and that's that 7 there multiplied by the root 2 over here, plus 10 root 5, and the last term is then multiply these two surds to give me root 10. So again, not a particularly nice one. So that's 70 plus 7 root 2 plus 10 root 5 plus root 10. So in this case, it doesn't look easier. We just rationalised it. So well done if you got that. Okay, so last example. I've chosen this one just so we can see what's going on with this one. Okay, so we can add fractions when the denominators are the same. So what we're going to do is multiply each fraction by sort of the denominator. So if you think about normal maths, if I'm trying to add 3/4 and something like 2/7, we're going to multiply sort of this fraction by 7, this fraction by 4, and then add them together. So all I'm going to do with each one is multiply to try and get a common denominator. I'm going to multiply this left-hand fraction by 1 plus root a. So you can see exactly what's going on. Let's have a look. So multiplying the left-hand fraction by 1 plus root a. And now if I multiply the numerator, I must multiply the denominator. So 1 minus root a and 1 plus root a, like that. So that's me multiplying this left-hand fraction here by 1 plus root a. So the numerator gets it, and so does the denominator. I'm going to do the same thing with this one, with a bit of a change. So this time, to get the same denominator, I'm going to need to multiply by 1 minus root a. So 2, 1 minus root a. And my denominator here, 1 plus root a, 1 minus root a. All I'm doing there is using the rules of fractions. So what we're going to get then? Now what we can do then, once we've got them written over the same denominator, we can just put the numerators together. So we're going to have 2, 1 plus root a, plus 2 lots of 1 minus root a, and at the bottom we're going to have 1 minus root a, 1 plus root a. Now at the bottom here, you can use FOIL on this, but you might spot this as difference to squares. We're just going to have 1 minus a. So if you want to do it the long way, then that's absolutely fine. Make sure you can get there though. So on the top here, we're going to have 2 plus 2, which is 4. And we're going to have 2 root a minus 2 root a, so they can disappear. So my final answer is 4 over 1 minus a. Okay? Here's yours to have a go at. It is a little bit more difficult. Pause it, have a go, and I'll run through it in a second. Okay, so I'm going to do this one at speed. So, same thing as before. I'm going to dive in straight to this third line here. So my common denominator is going to be 1 minus 2 root a, 1 plus 2 root a. So on the numerator, you're going to have 3, 1 plus 2 root a, minus 2, 1 minus 2 root a. So notice I've got the same numerator, and it sort of gains that denominator, sort of jumps up the top. You teach them that system like cross and multiply for add and take away fractions. It's effectively the same thing. It's not a method that I advocate, because with numbers, you look for the lowest common multiple. Right, so let's get that denominator sorted first, because I've got difference to squares there. So it's going to be the 1 minus this term here squared. So 2 times 2 is 4, and root a times root a is just a. So if you want to do it by, say, by longhand, make sure you can get there. So on the numerator up here, so we're going to have 1 times 3 is 3, plus 6 root a, minus 2 plus 4 root a, which leaves me finally with an answer of 1 plus 10 root a all over 1 minus 4a. If you got there, fantastic, well done. And these are quite difficult examples, these two. Right, so that's the end of this video. I'd like to complete questions 4 onwards of exercise 2b. Any more instructions will be given in Google Classroom for you from your teacher. Thank you very much for watching.